In this video, we're going to take a look at potential energy profiles for exothermic and endothermic reactions. So really, what is a potential energy profile? Well, basically, it's taking our enthalpy change diagrams and adding information about what happens during a chemical reaction. So it's basically used to show the energy changes occurring during a chemical reaction. There are a couple of things we need to point out here. So let's look at the exothermic reaction here first. And we're going to look at the x-coordinate or the x-axis, written here as reaction coordinate. Basically, it represents the progress of a reaction from reactants to products. So you can see that we're starting with reactants here. We're doing this little bump, and then we're going down to products. So our enthalpy change diagram, if you recall, just had this information here and here with our delta H pointing down. We're just now adding the other pieces of information in here. On the y-axis is potential energy. So just important to kind of point out there. Now, as we're looking at this progress of this reaction and we're going along the x-axis here, as the reactant particles are approaching each other, you're going to get some repulsion between the particles, and we're going to get partial breaking of bonds, which is going to cause the potential energy of the system to increase. And so the increase from reactants up to the peak here is something called the activation energy. And essentially, we're going to look at this when we look at kinetics of chemical reactions. So we'll look at this in more detail. But for now, activation energy is just the minimum energy that colliding particles have to have before a collision results in a chemical reaction. So like I said, we'll see more about this when we talk about rates of reactions. Now, in terms of what we've got here for an exothermic reaction, important to keep in mind that the products are lower energy than the reactants. And so we would say that the products are more stable than the reactants. Okay, so kind of keep that in mind. Looking at our endothermic reaction, essentially it's the same kind of diagram, except our reactants are now below our products. Our delta H is pointing up. And then our activation energy, again, is the difference between the reactants and up at this peak here. So you can see for an endothermic reaction, the activation energy is really high compared to this small little activation energy for an exothermic reaction. So endothermic reactions, the products are at a higher energy and then are said to be less stable than reactants. So these are basically the two different possible potential energy profiles for exothermic and endothermic reactions. That's it for this video. We'll see you in the next one.